Professor Frank will talk today for the challenges wastewaters from car wash to oily wastewaters.
Okay.
Please, Professor Frank.
Yes. Yes, thank you for the kind introduction, Professor Mava. I selected actually an interesting topic. I decided actually to talk about challenging wastewater, and specifically, I would like to talk about car wash and oily wastewaters. And basically, a quick outline of my talk, a quick introduction, and then we run into the topics, car wash wastewater and oily wastewater. And certainly, we round the whole thing up with some conclusion and outlook. I mean, the background is really for this talk is actually the sustainability development goal number 6, clean water and sanitation. I mean, safe water, sanitation, hygiene are essential for our human health. And basically, billions of people are lacking of these services by the year 2030 if they're not lacking already now. And the water demand is rising due to increasing population, urbanization, and increased needs for agriculture, industry, and energy. And basically, what is also known is actually that half of the world's population will face severe water scarcity at least 1 month a year in the future. And to make things even worse, I mean, we have climate change, which might even worse the whole situation. So we really need to find ways actually to improve water quality, but also recycle water in a good way. And that's basically I would like to talk about in 2 examples. One example is actually car wash wastewater. I mean, it's surprising. I mean, the total amount of water used for car washes worldwide is about 420 cubic meters per year. And when you have automatic car washes, they account actually for 55 to 60% of the car washes, but also 40 to 45% are done manually. So basically, that's I think it's quite important to have in mind, because for an automatic car wash, you need about 100 to 300 liters per wash. For manual wash, it can go up to 500 liters. The good thing is actually when you look at automatic car washes, they will already recycle quite a bit of the water. They achieve something like 70 to 80%. But actually to have also something for manual car washes, you need some sort of simplified system, which can be on a trailer, that people who are doing actually manual car washes can drive around, help people with the manual car washes, and recycle the wastewater. And that was actually the idea we had when we looked at car wash wastewater. We had a company in Sweden. They wanted actually to offer a service going to people, to their cars, wash the cars, and recycle actually the water they use for the car washing in an effective way. So when you look at car wash wastewater, I mean, you see the total suspended solids are about 200 milligrams per liter. You have COD 450 milligrams per liter. Then certainly, because you use also certainly washing aids, you have anionic surfactants. Cars, I mean, don't come without oil and grease. So you have both in the wastewater, and certainly based on this, also the wastewater will have a certain turbidity. The concept we came up with was actually, we had the wastewater tank, a paper filter, oxygenation, nanofiltration, and the clean water. And what you can see nicely here in the picture there, basically what we achieved with the different processes. So this was the original wastewater we collected. Then after the paper filter, you can see it's already improved. Then after oxidation, it's getting even further, and finally the final water after nanofiltration. I mean, you can see it's clear water, which you can hopefully assume with me that this water could be actually recycled and used for another car wash. Putting some numbers behind, I mean, we tested different nanofiltration membranes, and I mean, basically they achieved, when it comes especially to the total solids and turbidity, I mean, the process was working very, very well. I mean, conductivity, we were not so successful. It depends a little bit on the process, and the COD was also removed, depending on the membrane, very, very nicely. So when we looked at the membrane fluxes, that was certainly also important, because our unit should be actually as compact as possible, independent which membrane we use, or whether it was oxygenated or non-oxygenated car wash wastewater, we achieved very nice high fluxes. So basically fluxes in the range of 150 to 250 liters per square meter per hour. And that was actually quite nice. I mean, these are very much on the upper range, and we hope to actually achieve similar fluxes when we go to larger scale. So when it comes actually to the Carwash wastewater case, I mean, what we could see actually that we can total solid COD turbidity can be reduced significantly, allowing really to reuse this wastewater for another car wash, therefore reducing the total amount of water used for car washes. Oxidation might improve the fluxes of the membrane depending on the membrane type, and water flux could be cleaned, re-established by more than 60% using alkaline cleaning, using Ultraseal 10, and that was also very nice. Now I'm coming to another case study, oily wastewaters. Oily wastewaters are found in a great wide variety of industries. I mean, you find them as produced waters in the oil and gas industry, as bilge water in the marine industry, or for example, as processed water in the petrochemical industry. And when you look at just on the global produced water production alone, you will talk about 8.4 billion cubic meter per year. So that's a lot of water. And basically the main driver for this, actually, they are tightening regulation requirements for discharging the processed water and the growth of industry. And actually a simple process like ultrafiltration with polymeric membranes offers an energy efficient and compact approach for the industry to reduce oil in water down to less than 1 ppm. That sounds good. Let's look a little bit closer. I mean, there are different other technologies available. We have skimmers based on gravity density, coalescers based on collision, then centrifugal separators, again, centrifugation density, microfiltration, sieving mechanism, but certainly microfiltration is more open than ultrafiltration. So when we use ultrafiltration with the sieving mechanism, we have the highest efficiency. And that's actually quite good. When it comes to oil removal, we would like to have a process with a high efficiency. And that's basically the process we look at. Basically, we have a feed, idly emulsified oil waste, and the retentate is then the concentrated oily waste. And on the permeate side, we get 1 to 2 ppm water in the permeate. So very low oil concentration in the permeate when we use ultrafiltration. The membrane we used was actually a 3-layer membrane. It's a PVDF membrane. And yeah, on a polypropylene or a polyester support. And then actually this membrane has a very hydrophilic coating, a cellulose coating, and that gives the membrane a very hydrophilic feature. And this membrane called Aetna membrane we used. So I mean, the membrane is the commercial membrane by Alfa Laval, and it shows consistent performance over cleaning cycles and life cycles. I mean, the membrane is quite unique, and you can actually recognize it quite easily. It's actually a brown membrane, and actually the story is actually that they developed the membrane, and the R&D director was on vacation in Sicily, and he came back, and they showed him the membrane, and he looked at the membrane and said, "Oh yeah, the color reminds me about Mount Etna in Sicily." So that's the reason why the membrane has this surprising name, Etna membrane. When I did actually the slide, I put this volcano there, and I mean, when I showed the slide to my son, very happy about this volcano, he said, I mean, where's the volcano? There had to be a dinosaur. So therefore, it's a dancing dinosaur with it on the slide. So, I mean, it has nothing to do with membrane. It's just there for happiness. But looking a little bit on results, I mean, it shows actually an excellent performance for oil-free up to 200 ppm and oil emulsion and free oil up to 2000 ppm and oil emulsion up to 50%. And what you can see, I mean, also here, when you test the membranes, I mean, you get very high fluxes, about 100 liters per square meters per hour, for actually quite nice concentration factors. And what you can see here is the feed. And here, basically, you see the permeate. And I would like to look at 2 case studies I was a little bit involved in during my time at Alfa Laval. One was the treatment of bilge water and oily wastewater from an industry with low suspended solid concentration. I mean, the capacity of this case was actually 40,000 tons per year, and it was a batch concentration in the automatic plant. And they used actually the Aetna membrane 10 with 10 kilodalton molecular weight cutoff in an 8-inch spiral. And that was actually the concept. Simple is this. Basically, they had a big tank which they heated up. So they had in the tank, they had a phase separation. So they had an oil phase and a water oil phase. The oil phase went directly to separator. And then basically the oil water phase, we had actually here a paper band filter and then the Aetna membrane, and you get out very nice water, which was directly discharged to Baltic Sea. There was the oil monitor, but they never had actually any problems with the oil monitor. So that was perfect. And then the concentrate from the Aetna membrane was recycled into the tank against space separation, and then and everything is in a nice loop. This is actually how the plant was designed. So basically, we had a feed tank here, pressure 46 bar, and then here the membrane arranged in one loop. Very simple. And then basically we got out the permeate and the concentrate. And this was actually how the membrane looked like. So this is actually how the membrane section looked like on the plant. And this is actually the oil separator, which was also installed in the plant. And when you look at the production, I mean, we got nice constant fluxes over quite a long time. So basically, we did after a couple of hours, so 16 hours approximately, we did a CIP, and then basically we could recover the flux and do a new production cycle. And there was done a CIP once per day. The oil content was really 1 to 2 ppm in the discharge, and the plant is in continuous operation now for more than 5 years. And the energy consumption is about 6 kilowatt hours electricity per cubic meter permeate. Then I would like to look at a little bit more complex case. Basically, it's a second case study looking on processing of treating oily waste from ships, petrochemical industry, and offshore facilities at high levels of the spent solids. The capacity is actually basically double. It's 80,000 tons per year. And we have an Aetna 10 membrane again, in this case, in a 6-inch spiral module. The concept is starts similar. We have the tank where we put in basically the oil, wastewater, we have phase separation, but this time, because it's heavier wastewater, we use decanters to treat the oil phase, and then finally separators for the final polishing. So this decanter cascade with separator was for the oil phase, and then basically then we would take some of the light phase to actually evaporators as the final further polishing step. But what they found out was actually they could normally evaporator condensate is considered to be very, very pure and nice. But in this case, actually the evaporator condensate had still 200 to 300 ppm oil inside. So they had to do something about the evaporator condensate before they could discharge it. And therefore they installed actually a membrane unit. And actually they used the membrane in spiral configuration, and out they got actually a nice pure water stream, and then a stream which they could recirculate either into the tank in the beginning of the process actually, or in front of evaporation. And this is how the plant looks like. It's very much similar, the same as it was before. But in this case, actually, yeah, you can see, I mean, here we have the housing of spiral modules and basically some features of the pumps in the unit. So this unit is also running very, very nicely. And what is achieved is actually the oil content is reduced to less than 1 to 2 ppm in the discharge. This, the CIP, because actually after evaporation, even though it contains oil, it's not good enough for discharge. I mean, it's relatively pure water. So actually only every 5 days, there has to be a cleaning of the plant. And the plant is now in operation for more than 3 years, and the energy consumption is 4 kilowatt hours per cubic meter permeate. So let's then finish and round up a little bit. Yeah, what I wanted to show to you is actually Carwash wastewater can be polished by a simple process cascade, including nanofiltration for recycling, so that you really can reduce the Carwash water consumption. Oily wastewater can be polished with ultrafiltration to reach oil levels less than 1 to 2 ppm in the permeate. And I wanted to highlight with 2 case studies that actually membranes really can handle difficult wastewaters. And certainly there are ongoing challenges. I mean, for example, textile wastewater, tannery wastewater are still challenges. And actually with our joint project between India and Sweden, we want to look actually especially on textile wastewaters, which I think are still a major challenge. Thank you for your attention. A nice picture of the membrane.
Thanks, Professor Frank, for this very interesting presentation. We have the floor for one question, please.
I have two questions. I have two questions. First one concerning the Carwash wastewater. You didn't mention the pressure of the plant. So you mentioned only the volume flow, but not the pressure.
It was 15 bar, the nanofiltration.
15.
Yeah.
And the second question is concerning oily wastewater.
Yes.
Some of oily wastewaters contain also the solids. So this was not addressed here. So in this kind of oily wastewater, this didn't matter, the salts, or so I can imagine that if it is accumulated in the cycles, there may be an interaction or precipitation at a given point.
I mean, in this case, actually, it did not actually matter so much. I mean, we had no problems with it. So, I mean, we know that the plants are getting actually, there should be some oil salt inside because actually they get offshore water. But actually, in our process, we, as a membrane, we did not have any problem. It might be actually that actually we took the water was taken at the right position on the tank. I think that might be one explanation, but actually, it's a good point. They didn't have any problems with it.
Especially if multi-valent ions are prevalent and you do alkaline cleaning, and may consider also an interaction of the alkaline cleaning solution with the magnesium or calcium.
Yeah, but actually, one correction. Sorry, important to know. That's actually the thing. We use ultrafiltration, so the salt would go nicely through the membrane into the sea back because they discharge both sides discharge to North Sea. So we don't have an accumulation. So when we have the band filter, then we have ultrafiltration. Concentrate is going back. Salt would go with the water through towards the discharge towards the North Sea.
Yes, but sorry, one more.
Yes.
So I was once filtering water washing water also with ultrafiltration, and we could also see that a part of the magnesium and calcium was rejected, although we didn't expect it.
Yeah.
And so this was my question.
Okay. No.
Yeah.
In this case, we had no problems with it. Let's say it that way.
Thank you.
Maybe a short question. Suppose there is a startup company in India, and they found that they're using 10 plastic meters microfilaments for heating Carwash. They look at samples of the 34,
Yes.
and they were developing a technology, cheap technology. I don't know whether they knew about it. Maybe we can discuss.
Yeah, no, that would be interesting because I mean it's definitely an interesting area.
Yes, yes. I don't ask them technical, I'm asking technology.
Yes.
How much it costs? How much it costs?
What?
How much cost? Which is cost.
Which of the system?
So.
I mean,
I
it's we look about. It depends certainly on the size. The size we look for the person who is actually running around now in Stockholm. We looked at about 50,000 euros with a trailer, everything is included.
50,000 euros.
Yes, and he was happy.
So she. Commercial now, is it commercial?
It is commercial, yes.
50,000.
Yeah, but the thing is actually it's not a big system. I mean, we don't talk about a huge plant. Not it's significantly smaller than what you saw. So, but actually the thing is actually also the other two plants just important. I mean, they are commercial units, so basically someone did an economic evaluation whether it's worth or not.
I think we can complete after this. Yeah, you're welcome. You're welcome. We will move on.